Assignment 1 for Group 13. Our group members consist of Danuchario, Cha Nguyen, and Michael Verghese, and today we'll be presenting Lotus Law. Lotka investigated Arthur productivity and modeled it mathematically during the last century. Essentially, his law describes the very regular patterns that are seen in subject bibliographies when authors are listed by the number of times they have published. The law Lotka discovered relates to the productivity of scientists. It discovers the frequency of publication by authors in any given field. It states the number of authors making n contribution is 1 over n to the power of a, those making 1 contribution, where a is nearly always equal to 2. More plainly, the number of authors publishing a certain number of articles is a fixed ratio to the number of authors publishing a single article. As the number of articles published increases, the author producing that many publications becomes less frequent. In essence, it's saying Lotka's law explains that a small number of authors write many publications and that a great majority of authors contribute only 1. The number of publications and the number of authors producing that number are inversely related. Lotka's laws come from 2 different fields of study. The first one is bibliometrics, which is a study of methods to quantitatively analyze scientific and technological literature. And the second one is Zipf's law. Zipf's law models occurrences of distinct objects in particular sorts of collection. As the formula shown in the previous slide, the formula for the number of authors producing n publications is equal to 1 over NA of those producing only 1. Thus, n is equal to the number of publications, and the a is almost always equal to 2. If we wanted to apply this formula to a quick example, we would use the number of authors would be equal to 7 as n, and our a would be 2. And as a result, our answer would be 2.04%. So basically, the answer would be about 2.4% of 1 author who contributed 1 publication. Continuing with the example from last slide, this table shows the number of authors that have written a number of articles. If you look at the table, you can see that the number of articles written by 100 authors is 1. And as we go up the table, the number of articles written by each author is inversely increased. So in the end, we have 10 articles written only by 1 author. So what is proven with Lotka's law? It shows that a great majority of authors produce a small number of publications, and that a very small number of authors produce a large number. Lotka's law is also referred to as inverse squared law. The formula and the empirical evidence supports the inverse notion. So how does Lotka's law relate to information technology? Lotka's law can help us understand the dynamics in many sectors within the information technology field, such as websites that take advantage of user-generated content, social networking websites, and open source development. A few examples of these can be seen on this slide, such as YouTube, Android, Wikipedia, and Reddit. One of the points mentioned in the previous slide was open source software. With open source software, you have multiple open developers producing for our community, and it's all free software. So it's users contributing whatever they want to contribute to the strength of the product.
The Linux software map, or LSM, has existed since the early 1990s. The LSM contains metadata describing Linux software. Linux software map is a standard text file format for describing Linux software. It also refers to the database constructed from these files. LSM is one of the standard methods for announcing a new software release for Linux. If a Linux program is to be distributed widely, a LSM file may be created to describe the program. Using the Linux directory tree from Biblio, which has one of the largest Linux archives available as an example. All LSM files in Biblio directory were examined, revealing 4,503 total files, with 3,341 unique authors. As you can see from Table 1, 2,737 authors were linked to only one LSM file, and 391 authors were linked to only two LSM files, and so on. As shown in Figure 1, the actual versus the predicted numbers aren't quite equal. According to Lotka's law, by squaring the errors and performing numerical computations, we can find the value of n that makes the error rate minimal. As you can see in Table 2, all of the columns remain the same with the exception of column 5. Column 5 is now called prediction error. It involves the square of prediction error, column 2, minus column 3. The most efficient exponent of n turns out to be 2.82, which has the lowest total prediction error with a total of 666.92. Now with the exponent of n equaling 2.82, Figure 2 shows the accuracy of actual versus predicted lines, which are now essentially on par with one another. SourceForge is a web-based source code repository. It acts as a centralized location for software developers to control and manage open source software development. It was the first to offer that service for free to open source projects. SourceForge hosts over 26,000 projects with over 240,000 registered individuals. However, not all individuals are associated with a project. Each author is given a unique developer ID when they register with SourceForge. An analysis similar to LSM data was conducted on SourceForge data. Again, in Table 1, when the exponent of n is equal to 2, the error rate was off the charts. In Table 2, when the exponent of n equal to 2.55, the error rate was drastically reduced to 226,010.56. So why is this important? Based on the data we have just shown you, the use of Lotka's law and bibliometrics provides us with data that is beneficial in understanding the behavior of open source projects. As the technology world grows, open source software projects are becoming more and more important. With the advent of open source mobile platforms such as Android and the soon-to-be open source WebOS, it is clear that this type of development will not be going away soon. Thus, it is important for us to understand as much as we can about this dynamic type of software development.
In conclusion, Lotta's law is applicable to many aspects of technology as well as its original intent. To review, it consists of a formula 1 over n to the power of k, which is a percentage of the number of authors who produce one publication. As we discussed today, two key examples in the open source technology were, as you saw in the chart, the Linux software map contributors and the SourceForge developers are inversely related to the number of LMS files worked on, and on SourceForge, the number of projects worked on, respectively. These two pillars of technology solidify the validity of Alfred Lotak's mathematical data analysis. In discussing open source and Lota's law fits the trend behind open source technology, and it's clearly seen that Linux and SourceForge are two big names that will remain at the forefront of the technological platform.